Assalamu alaikum. I am Ibrahim Musa and I am here to present you this Telekilaas on radioactivity, which is a grade 10 physics topic. So before we start, let us discuss about the objectives of today's lesson. As you can see, by the end of this lesson, you should be able to discuss the random nature of radioactive emission, identify alpha, beta and gamma emission by recalling their nature, their relative ionizing effect, their relative penetrating abilities, and demonstrate understanding of background radiation, describe the detection of alpha, beta and gamma rays. Now, first of all, let us recall what an atom is. You must have studied in chemistry. An atom consists of protons and neutrons and electrons. As you can see, inside the nucleus, we have the protons and the neutrons. And surrounded by that is the electrons orbiting around the atom. So, and in a normal atom, it is said to be electrically stable. When we talk about atoms, atom comes in families. So, we call that isotopes. What is an isotope? Isotopes are atoms of the same element having the same atomic number but different mass number. Let's say, for example, hydrogen. This hydrogen, it has two isotopes, which is deuterium and tritium. The only difference between these three particles is that the number of neutrons are varying. So, we can say that the number of neutrons inside the nucleus of the atom is what defines if it is an isotope or not. So, as you can see, deuterium, it is having one neutron extra compared to hydrogen. And then tritium, it has two neutrons in extra. So, what happens when it is having extra neutrons? So, what happens here is, it's a matter of instability. So, isotopes are said to be stable and sometimes unstable. When we talk about stable nucleus, the stable nucleus is the particles in a stronger nucleus is bound by a strong nuclear force. So, this force ensures that the protons and neutrons are strongly held inside the nucleus. So, that is why it is said to be a stable nucleus. But what you need to understand is, when we talk about an unstable nucleus, the case is different. Sometimes the nucleus may have extra number of protons and it can sometimes have extra number of neutrons. As a result, it becomes unstable. This process is what we call as radioactivity. So, in this state, radioactive decay occurs. Now, what you need to understand is, what is radioactive decay? Radioactive decay is a spontaneous process by which an unstable nucleus emits radiation and tries to become stable. So, this process is called radioactivity. Now, there are three types of radiation that it emits, that is alpha, beta and gamma. Now, I will be focusing on the properties of each alpha, beta and gamma. Now, I will be looking into the properties of the radiation. An alpha particle, it contains two protons and two neutrons, and then it is very similar to helium nucleus. So, it can be represented by the helium symbol as well, but unlike a helium atom, it does not have any electron. So, therefore, it gets an overall charge of +2 because of the absence of electrons. And what you need to know is, it is relatively large. So, when it moves through air, it loses its energy and it cannot penetrate to further distances. So, it can only travel few centimeters in air, and it can be easily absorbed by a thin sheet of paper. And because of its big heavy size and due to the +2 charge, it can be very strong ionizing. Now, when we talk about beta particles is a beam of fast moving electrons. it does not have any mass. But you might be wondering, from where is this electron coming? It is not coming from the orbital of the atom, but it is a neutron converted into a proton and an electron. So this electron is bombarded out at a very high speed. And beta particles, it does have a moderately ionizing power, and the penetrating power, it is few meters in air. It is quite small compared to alpha, therefore it can travel further, and it can be stopped by a 5 millimeter aluminum sheet. When we talk about gamma rays are nothing but pure energy. So it is a wave of electromagnetic radiation which is emitted after an alpha or beta radiation. So in order to remove, or in order to get rid of excess energy inside an atom after radioactivity, a gamma ray is emitted. It does not have a mass and a charge, and it passes through materials, so which means it is very, very weak in ionizing, and it can travel to very, very long distances. It can be stopped by thick sheets of lead, and or it could be stopped by concrete. Now, the properties that I just mentioned, I'll summarize that in this table. As you can see, alpha radiation is alpha particles, or which is similar to helium nucleus. Beta radiation or beta particles, it's a beam of fast moving electrons, and gamma radiation is high energy electromagnetic radiation. And there, as you can see, those are the symbols of alpha, beta and gamma. And as you look into the charge, alpha radiation, it has a charge of +2, beta radiation, it has a charge of -1, and gamma radiation does not have any charge. So for this reason, as you can see, alpha and beta, it does have a charge. For that reason, alpha and beta can be deflected inside an electric or a magnetic field, but gamma radiation does not get deflected in a magnetic or electric field because it does not have any charge. When we look into the penetrating power, alpha radiation, it has a very low penetrating power because of its high energy. It can travel into few centimeters in air because it collides with the air particles or any other the medium it travels, and it loses its energy. When we talk about beta radiation, it has a moderate penetrating power since it is very, very small compared to alpha, and gamma radiation, it has a very, very high penetrating power. When we talk about the shielding, so alpha radiation can be stopped by cloth or paper, beta radiation can be stopped by metal foil, which means around 3 millimeters of aluminum, and gamma radiation can be stopped by lead or concrete. And you must note that it is not completely shielded because it's an electromagnetic radiation. And then when we compare the ionizing power, alpha, it has the highest ionizing, gamma, it has the least ionizing, and beta has a moderate ionizing power. So now we'll be looking into detection of alpha, beta and gamma radiation. In order to detect, we are going to use a GM tube. So it's a short form of Giga-Müller tube. So this GM tube is made up of a cathode and an anode, and then it is connected to a power supply and a rate meter, or what we say, it can be said as a count meter as well. Now, as you can see, inside this region, we have argon gas, low pressure argon gas. So you might be wondering why we are using argon gas. Argon gas is an inert gas, so it does not undergo any sort of reaction. So when radiation passes through this thin mica window, now you might be thinking, why can radiation pass through this window there? It is very thin and it's very delicate, and then it can easily break. So radiation can easily pass into the GM tube and ionizes this. Now, as you can recall, in chemistry, you have studied that in electrolysis, when we dip 2 electrodes into an electrolyte, there is a electron and ion movement inside the electrolyte, and then it produces a current flow. So similarly, the same sort of ion ionization in between these two regions, it creates a current flow between the anode and the cathode. And as you can see, the whole circuit is incomplete, but due to the ionization inside the GM tube, the rate meter starts to give out a reading out here. So which means greater the ionization, greater will be the reading detected at the rate meter, which means if it allows alpha to pass in, there will be a greater amount of ionization. That means you will get a greater reading at the rate meter. When beta passes, there is going to be a moderate ionizing, which means the rate meter will give you a moderate reading. And then if gamma passes into the GM tube, there is going to be very weak ionizing, and then you'll get a very low reading. Now, as you can see inside this, in this video, so the radiation passes inside and the argon is getting ionized. So which means it is supplying a lot of electrons there, and as a result the circuit completes and then you are getting a reading. So as I mentioned earlier, greater the ionizing, greater will be the reading that you are getting, and lower the ionizing, lower will be the value you are getting at the rate meter. Now, there is something I want you to understand, which is the background radiation. So when we use a GM tube in order to take measurements of radioactivity, we will get, despite of the radioactive source, we will get some additional readings. So that reading is what we call as the background radiation. So what is the background radiation? It is a measure of level of ionizing radiation present in the environment at a particular location. So the background radiation, it varies from place to place. It may not be the same. You might not get the same background radiation here you get here in Maldives, and the value may differ when you go to another place in Europe. So it does not have a fixed background radiation. We don't get a fixed background radiation. And a quantity of activity gives an indication of how the radioactive substance is. The activity is the number of radioactive atoms which disintegrates and emits radioactivity per second. So activity is a keyword here. So it's the number of disintegrations that is taking place in every second. So please do remember this keyword, activity. Now you might be thinking, from where are we getting this background radiation? There are multiple sources. So I have listed out some here. So number one, as you can see, it's cosmic rays. What is that? That is the radiation that we are getting from the space. So it can be coming from the stars, it can be coming from the sun. So whatever it comes from the space, we call it cosmic rays. Rocks and soil. So there are a lot of radioactive isotopes there inside the ground in some of the rocks, and then it also gives out radiation. And also during mining, some of the rocks will be unearthed and it also increases the radioactivity level. And sometimes in living things also, as you may understand, everyone, we all have carbon-14, and then once the living things die, it becomes radioactive, and then that can be used for carbon dating. And then from nuclear wastes, so we all know what nuclear wastes are. So when they dispose these, after the nuclear reactors, when they dispose the nuclear wastes, we'll get a lot of nuclear radiation. Now, let us discuss on certain experiments or some ways in which we can use the GM tube in order to identify. Let's say, for example, if a given source is emitting alpha or beta or gamma. So in this example, we are going to make use of a GM tube and let's say a given source, and then we are going to identify if the given radioactive source is emitting alpha, beta or gamma. In the first step, what we need to do is we need to identify the level of background radiation in the given location. So let's say, for example, in a certain place, I'm trying to identify the what kind of a radiation a given radioactive source is emitting. So first we need to identify the background radiation. So that should be the first one. And then what you do is you open the radioactive source and then you place it few centimeters. So you place the GM tube few centimeters from the radioactive source. And then you might be thinking why we have to place few centimeters from the radioactive source. So as I've mentioned, alpha particles cannot travel to longer distances. So for that reason, we are not sure if this is emitting alpha or beta or gamma. For that reason, we need to place it as close as possible so that we are assured that if alpha is emitted, all of the alpha is given access into the GM tube. So what happens when an alpha is there? We are getting a reading here. So even if alpha or beta or gamma is there, if it is radioactive, it will be emitting, it will be ionizing in the GM tube, and then we are going to get a value at the rate meter. Then what happens if we want to make sure that if the radioactive source is emitting alpha, we place a thin sheet of paper between the radioactive source and the GM tube. So what happens? We all understand that thin sheet of paper cannot, we will stop all the alpha particles. So if this radioactive source is emitting alpha particles, this thin sheet of paper will stop any alpha particle that is there. So the rate meter, the value at the rate meter will reduce if the radioactive source is emitting any alpha particle. Now let's say, for example, if this source is emitting beta particles, so what are we going to do? We are going to place, instead of paper, we replace the paper with a 3 millimeter aluminum sheet. So this aluminum sheet will hold all the beta particles, and if it emits any beta particles, it will stop, and it will also stop all the alpha particles as well. So if this is emitting beta particles, the rate meter will show a reduced value. So which means if there is any more radiation there, that whatever reading is, it is being contributed by either gamma or the background radiation. Now you must remember that when we talk about background radiation, it can easily fluctuate, so it may not have a fixed background value. So this setup can be used in different ways. You can improvise it, so based on the requirement or based on what you want to identify in terms of ionization, or in terms of identifying what kind of radiation it is emitting, you can use this same arrangement, but you can improvise any way you want. So let us summarize on what we have learned today. So how is radiation produced and emitted? So it's as we have explained, it is produced, radiation is emitted from atom, inside an atom, an unstable nucleus. In order to become stable, it undergoes radioactivity and emits radiation. The types of radiation, so when an atom undergoes radiation, 3 types of radiation is emitted, namely alpha, beta and gamma. And we have studied the properties of the radiation in terms of ionization and in terms of the penetrating power. And we have studied about the GM tube, how a GM tube works, and identification of the background radiation and what actually background radiation is and how radiation is detected. So these are some links that I have referred to. So that sums up today's lesson. So I'll be meeting you with another lesson. So thank you once again, and wassalamu alaikum.